Hi everyone, John here. Welcome back to my channel. So today I'll be talking about the basic concepts like abstraction, encapsulation, inheritance, and polymorphism. So without waiting, let's get started. So first I'll explain about class and object. So let's understand this first. So class, this is the core of any modern object-oriented programming language such as Java, C#. So it's the blueprint of an object where that will contain variables for storing data and functions for performing operations on these data. Whenever you define any class, so I have given an example over here, you can see. So class employee, and I have created two instance variables of type integer and string. So whenever you define this, this is not going to occupy any memory space. So this is only logical. So the moment you create an instance of this, so the instance is what we call as object. So the moment you create that, then that object will occupy a memory from heap, and that reference variable will occupy memory from stack. So this is the instantiation of a class, you can see. So where employee e1 equal to new employee, the moment you use this new keyword and then this class and this double bracket, so at that time that object of this class gets created and it occupies a memory in heap, and this is the reference, this is the object. So reference gets stored in stack and the object gets stored in heap. Okay, so object, as I said already, is an instance of a class. So I can give you a real world example where you can relate this class and object. So as I said, class is a blueprint. So you can take it as an example like the engineering plan. Before building any house, you get an engineering plan, right? So that is the logical structure that where the definition would be there, like how we need to proceed for creating that building, right? So all these things, all these calculations, documentations would be present in that engineering plan when we get this from an engineer, right? So and using that engineering plan, we can build a house. That house you can call it as object, and that engineering plan you can call it as class. So using that class, using that engineering plan, you can create as many houses you want, right? So that will be of similar structure. So whenever you'll be creating multiple objects of a class, it will be having that similar structure, but the data would be different, right? So the instance, so you can instantiate all the instance variables, and you can uh, you know depending on the data, the output of all the methods which will be present in that class, so it will be different. It will vary from object to object, right? So I'll give you a demo. I'll go to Eclipse. Okay, here I have created this employee class. Okay, so here I have defined employee ID and employee name, so integer and string type data, and the access specifier is default. So this thing I'll be explaining in my next tutorial, like what all access specifier we use, like public, private, protected, and default. So I'll just show you how we create an object of a class. So this is the class. So we are defining these two instance members. Next, I'm creating this main function. So this is the one where execution starts. So before this static block, of course, executes, but this is the one which is the starting point where the JVM will trigger this. Whenever we execute this program, JVM will find out the main function of that particular class and it will start executing. It will trigger that. So execution always starts from main class. So this is one of the interview questions you might take a note of. So here the method should be public, as you, this is a prerequisite, the public and static. So these should be there, and void obviously would be there, and main, and it should take string arguments. So that method signature will only be hit by JVM when it will start. So any other signature if you'd be putting, overriding, overloading this method, it will only trigger this one with this particular signature. You can alter this static and public, but you can't alter these stuff. So always the return type should be before the name of that particular method. So it should be main here. Okay, so I mean that will be explaining later. So here you can see the object of employee class is created, and here what I'm doing is, so this employee one is a instance of this employee class. Okay, so this employee ID and name would be different. I mean, based on how I initialize it, so it might be different. Okay, so employee id and name, these are associated with employee one. The moment I create this employee one from this employee class, this object, so this object would be having a copy of employee id and name in its own memory. Okay, so second, I created another object, and then I assigned these two instance member to different variables. Like here, I have assigned 100 and Jack, and in the second object, I assigned 100 and Jones. Then I'm trying to print the name of both the objects. So here I'll print it, and you can see the first output is Jack and second output is Jones. So it's like these are two different objects. Okay. I'll go next slide. So next thing I'll be explaining is abstraction. So what is abstraction? Okay, so abstraction is to represent the essential feature without representing the background details. So abstraction lets you focus on what the object does instead of how it does it, right? So I'll give you a real-time example, like file reader class, you have that, right? So what internal implementation it has, you don't need to worry about that, right? So all these things are abstracted out from you. You can directly go ahead and use it in your method, right? So if anyone doesn't know, I mean, obviously you won't be knowing file reader class. So it is a utility class which is provided by Java for reading files. Okay, so I mean, I'll be creating tutorials for that, how to read files and all. So then you can refer. So this is like this is a utility class which is provided by Java API only. So that thing you can use for reading classes, but for using it, you don't need to know how it handles a file. You just need to know how to call that particular method, but you don't need but you won't be having any idea what it does internally. So how it is handling that file, how it is maintaining the file security, and how it is allocating the memory for that file. So these things are hidden from the consumer. So this is called one example of abstraction. Another example I can give, like for example, mobile phones. So basic thing is like you can call and send an SMS. So for example, these two functions, so these are common for every mobiles, right? So these things you can abstract it out. You can create an abstract class, and you can provide this two abstract methods and give the implementation of this basic call and send SMS functions, and any other mobile who extends this will be having access to those two methods, and they can do the similar functions, and if they want to override it, they can do it. But I mean, basic things as it would be there, so they need to do it. So like iPhone, Sony, Xiaomi, those mobiles can extend that particular abstract class, and they can give it they can use those two functions, and on top of it they can override when they want, obviously, and if they don't want it, they can provide additional functionalities, right? So this is abstraction. So encapsulation is information hiding. It enforces access to the internal data in a controlled manner. So what I mean by this is, for example, a mobile manufacturer is manufacturing a mobile phone, right? So so whenever you make a call from your mobile, so you don't know what it internally does when you type a number and you just press the button call, right? So these things are encapsulated inside a method, inside a class, inside a separate class, which you don't have access to, right? So only thing you know is how to press the call button, but these things are encapsulated, right? So it is hidden out from you, right? And another example would be TV, right? So the moment you click on this power on, the moment you click on this channel change, internally it does a lot of things. Those things are not exposed to you, or you don't know, right, how it does it. You don't have access to that. You can only change the channel. So for end user perspective, you just keep it simple. They just keep it simple, right? So you can operate it without knowing any internal details. So all these things are hidden from you. So this is the example of encapsulation. And here I can tell you like how we enforce encapsulation in a class. So there are access specifiers, right? Public, private, protected, and default. So by this, here you can see this class foo is there. So it is not encapsulated properly. It's bad. The coding standard is bad. You can see there is a instance member not encapsulated. It is a public member. So anyone can create the object of this class and can change this particular variable, right? So because it is public, you exposed it to the outside world, so anyone can change this variable, so you won't be knowing what it is doing and you don't have control over it, right? So sorry, yeah. So next class, you can see here I made it private. That means it is restricted to the outside world. You can only access a private instance variable inside this class, so you can't access it outside. Okay, and the only way to change the variable value is to call this method, and this method enforces a range check. So if the range it will satisfy, then only it will assign that variable. So this is properly encapsulated inside a method, right? So the way we encapsulate things. So encapsulation means, you can say it in another way, that the way we structure things, the way we create the data members methods and put it inside a class, we maintain package structure. So that is called encapsulation, and we uh, put proper checks that this is safe from the outer world. We don't expose it, right? So that's all about abstraction and encapsulation. Next thing is inheritance. So inheritance is the mechanism by which an object acquires some or all properties of another object. So here in my example, I have this class calculation. This has one instance member like result and two methods, subtract and add. And this class extends this calculation method, and it has another method multiply, and in main method I'm doing this. So I'll explain this in Eclipse. So let me open Eclipse, how it does and how we do inheritance over here. So why we need inheritance? The first question I want to answer, the reason we need inheritance is we don't want to repeat the codes. We don't want to repeat the functionality which is already given by another class, right? So it so the way we do it is by inheritance. So for example, a class A is there, and in class A two methods are there, and in class B we need those two methods. So we don't need to copy the methods which are present in the class A. What we can do is we can extend the class A. So in this particular example, you can see the calculation class. So this calculation class provides the implementation for subtract method and add method. Okay, for example, I have another class. So in case you are wondering why two classes are present in one file, it is possible in Java, but only one of them should be public. Okay, but internally it will be creating two separate classes, two separate class files. So that will explain later. So here you can see, so yeah, as I was telling you, calculation class is there. For example, we need the subtract functionality and add functionality in MindCalc class. So the way we can reuse that subtract and add method is by this keyword extends. So we can extend the calculation class. Is you can see here I have written extends calculations. So you can extend only one class, and implement you can extend I mean n number of classes interfaces you can implement. Okay, you can extend only one class. So multi-level multiple inheritance is not supported in Java because there would be confusion. Like this subtract method would be present in a lot many in suppose two classes, and we're extending these two classes over here, so it will be difficult for this program to know which method to call, because that implementation is given by both the super classes, right? So it is very difficult. So because of that, Java doesn't support multiple inheritance. Okay, so you can extend only one class. Okay, So here you can see this multiply method, that is an additional method which is given by this class, and inside this public static void main method I have initialized two local variables, a equal to 20 and b equal to 20. In case you're wondering why we need to initialize it, you have to initialize local variables. So my calculator calc equal to new my calc. So what I'm doing is I'm creating a object of my calc class. Okay. So then what I'm doing is I'm using this object to call this add method. So what it is doing internally. So when the moment you extend this calculation class, you have access to this method, and this instance member. So you have access to these three. So here you can see in this uh, in this particular class we haven't initialized result anywhere, so it is referring to this only, this initialization. Okay, so the moment I do this add call, so then it is calling this method over here and it is getting us the result, and it will print it. So I have given this out statement over here, it will call this add method. So I am reusing the method which is defined in calculation class by using extends. So this is the benefit of inheritance, and same goes for subtract. So the moment I call this subtract, it calls the parent method, because in this class it doesn't, it's like copying, these two methods over here. The moment you do that, you have access. It's like these two are present virtually over here, so you don't see it, but it is actually there. So it's like calling the same function inside that class. It's like that, you can assume, right? So, and when you call this multiply, it calls the multiply method which is present in this class. This is inheritance. You inherit the methods, data members of the parent class. Okay, so always it's like the child class will have access to the parent class, but from parent you can access the child. Okay, so this is all about inheritance. Next thing is polymorphism. So what is polymorphism? Polymorphism means to process objects differently based on their data type. So it's like, I'll give you a real-time example, like car. It has a gear transmission system and it has 4 front gears and 1 backward gear. Okay, so whenever you accelerate the engine, so depending upon which gear, whether it is forward or reverse, the amount of power, the moment, the direction, that will be different, right? So that will be different. It is based on the runtime, right? It depends on the situation. So there are two kinds of polymorphism. So when I'll be explaining it in code, you'll get a good understanding. So there are two kinds of polymorphism in Java. One is static polymorphism that we call as method overloading. So method overloading is possible only when you change the number of arguments, and it is possible when you change the data type of the arguments, the parameters which are taken by a method. But method overloading is not possible by changing the return type of the method only, because and during uh, you can't say the return type as long as it has already written. As long as you don't invoke that method, you won't be having any way what could be the return type. So overloading is not possible. This is actually compile time polymorphism. This is another name of static polymorphism is compile time polymorphism. So during compile time, it has no way to know what would be the return type of that method. So during runtime only, it will come to know that. So method overloading is not possible by changing the return type. So what I mean by these three statements, I'll explain this in Eclipse. So bear with me. So here, so this class, this has add three methods which are named as add only. Okay. So what I'm trying to make you understand is, so here you can see this method is taking integer a and integer b as the parameter, and this method is taking 3 parameters and all are integer. Third method, it takes 2 parameters, one is integer and float. So these three methods, they are having similar name, but what is the difference? The number of argument is different, the number of parameters is different, and the data type is different. Okay, this is called method overriding. So how it is being used in this particular class, I'll show you. So here you can see I'm creating the object of this class, and I'm adding and I'm calling the method and passing some arguments. So depending on the type of arguments which I'm passing, so that appropriate method would be called. So for example, here I'm calling this add method and I'm passing two integer values. Okay, so what it'll do is it'll find a method which accepts two integer values. So it'll find this method. One second, some issue. Yeah, it will find a method which accepts two integer type data types, and then it will invoke that particular method. And for the second case, we are passing three integers. So depending on the number of inputs and its data types, it will invoke the correct method, whichever is uh, appropriate for that. I mean, whichever method, whichever method can handle those many parameters of that kind of data type. So it will call that appropriate method. So in the second case, it will be calling the second add method, which takes three integer parameters, and in the third case we are passing an integer value and a float value, so it will call the third method. So I'll run it and I'll show you. So here you can see the first add, second add, and third add. So first one it will call the first one, second one it will call the second add, and third one it will call the third add. So that's all about method overriding. As I already mentioned, by changing only the return type, it's not possible. Method overloading is not possible. Okay, you can only do method overloading by changing the number of data types and the type of data it is taking as parameters. Okay. So next thing would be dynamic polymorphism. So that we also call as runtime polymorphism or method overriding. So what we mean by that? I have an example over here. I'll show you. So let's say there is a class bike. It has a run method, and this class, another class, it is extending that bike class, and it has another run method. This is overridden. Okay, so it is extending another parent class, and it has given a overridden run method. And third class, it is again extending this bike class, and it is giving an implementation of run method. Okay, so what I'm doing inside main class, so this is just a tester class I created. So uh, here I have created an instance of bike and bike, because you guys will be confused if I do these two first. So I thought of doing this first. So this is not runtime polymorphism. This is just normal class run. Okay. So the moment I'm doing instantiating the bike class, and I'm calling this run method, so it's obvious that it will call the run method which is present in the bike class. Okay. Let's see this third statement. So bike equal to new Yamaha. So what is meant by this? So what we are doing here is we are creating an instance of the child class, and we are using the parent class reference, right? So the moment we call this run method bike.run, so what it tries to find is it will try to find the run method in the objects class. So here the object, what is the object? It is the object of Yamaha class, right? So it will run the method which is present in Yamaha class. So it's not dependent on the reference, it's dependent on the object type. So whenever we call this run method, so it will invoke the method which is present in Yamaha class. Okay, so in this case it will call this run method, and it will print out this statement. Okay, let's go to the fifth statement, this one. Suppose bike1 equal to new Honda. So in this case we are creating an object of Honda class, and we are assigning this object to its parent class reference, right? So parent class can obviously hold the object of any child class. This is what you should know, that parent class can hold the object of child class, but child class can't hold the object of parent class. Okay, so in case you do that, that will give you a class exception. You should never do that. That will be a runtime exception. That will be a class exception. So in this case, whenever we'll be doing this bike one dot run, sorry, I missed the one over here. Whenever we'll be doing this bike one dot run, it will be calling the method which is present in this Honda class. So it depends on the object, as I already said. It depends on the object, not on the reference. So it will call the run method which is present in this class. Suppose in Honda class the run method is not there, then in that case it will be calling the parent run method. So in that case it will be this one. If in Honda class this run method won't be there, so then in that case it will be calling the parent class. Okay, so it's like dependent during the runtimes. Why it is calling as runtime polymorphism? Because during runtime, it decides like whether the run method implementation is provided by this or it's not present. So in that case, it will be invoking the run method which is present in the bike class. So the moment you write bike under run, it doesn't validate whether the run method is present in Honda class or not. So during runtime, it comes to know whether the run method is present in the child class or not. So in that, if it is not present, then it will call that child class run method. If it is not present, then it will call the parent class run method. So this is what we call as runtime polymorphism. So I'll try to run it and I'll show you the result. So you can see in the first case, this is normal. This is not runtime polymorphism. Second case, you can see it calls the objects run method. Third, it calls the objects run method. Let's say I'll remove this run method over here. As I was telling you, it will call the parent class, right? So the moment I do that, in the third case, you can see it called the parent class run method, right? In the third case, you can see this run and this runs are associated. Okay. And another thing I was telling is you can't hold a parent class object in a child class reference, right? So what I meant by that is the moment you do this, for example, you do like this equal to new of bike. Okay, this is not possible, right? So you can see this can't convert bike to Honda, but you can do a casting over here and you can avoid this compile time error. This is illegal. Okay, so the moment you do that, it will give you a class exception. You can see class exception. This is not possible. This is only possible. This is only possible. Okay, so that's it, guys. If you like my video, please give me a thumbs up and subscribe to my channel because I'll be uploading similar kind of videos. And I hope I have I hope this information has been really helpful for you. Thank you. Over and out. Bye.